right, everyone. Welcome this evening to our 10th webinar in the series. My name is Dana Ripper. Here with me is Ethan Duke. We are with the Missouri River Bird Observatory. Our mission is conservation via science, education, and advocacy. I have one announcement before we get to Robbie this evening, and that is that we have just announced a new webinar series. I know everybody wants to continue spending their Monday nights watching webinars with us. This is 4 webinars in April. We have some great speakers coming up. I know a lot of folks that are on this webinar and have been on our webinars this winter are folks with pretty deep background and experience. Master naturalists, master gardeners, folks who are really intaking this information and processing it and using it. Our April series is a little bit more of a, sort of meant for beginners. So I hope that you share it with your friends and family and that you enjoy it as well. So I'm going to try to put a PDF in the chat. Hopefully folks can see it, but I'm also going to put the link. And yeah, please pass it on. So this evening, we have Robbie Doerhoff. I first saw Robbie present on this topic as part of the Missouri Prairie Foundation's webinar series last year. And it was one of the best and most informative presentations that I saw all year. And as soon as I got off, I emailed her and said, will you please present for us as well at MRBO? So we're really happy to have you tonight, Robbie. Thank you for being here. Robbie is the forest entomologist for the Missouri Department of Conservation. She received both her BS and MS in biology at Truman State, studying Belizean katydids for her thesis. Robbie is originally from a farm in Lawrence County, but now enjoys living north of Columbia with her husband and sons. So Robbie, please take it away. Thank you very much.
All right. Thank you, Dana. I really appreciate the invitation tonight. And thank you to everybody who has logged in this evening. I know it's a beautiful day outside and it's still sunny out. So I really appreciate you coming here tonight to listen to this. So tonight I'm going to be talking about Dicamba and 2,4-D and how that relates to trees in our current setting. These are old herbicides, which I'll get into in just a little bit. But, this is a really kind of a cheeky title. These old herbicides are definitely causing us some new problems in the last handful of years. And it's something that I want everybody to be aware of so that you can be on the lookout for it. But then also, join me in thinking up some solutions on how we can fix this issue long term, because that's really what we need to do as people who love the natural resources. So I just want to start by saying, yes, I'm the forest entomologist, and entomology is the study of insects, not the study of herbicides. So for me, this has been a really big learning curve over the years. And what I'm trying to do tonight is distill the information in this pretty complex situation into something that makes sense for a 1-hour webinar. I hope I achieve that. But don't be surprised if you come away from this with a whole lot of questions. And hopefully we can get to those at the end. But this is a complex topic. It's something that's been building over time. And it's something that is really near and dear to me. Once I started learning more about this, the more passionate I became about the topic. And the more I started to speak on it, not only in Missouri, but with my forest health counterparts across, the Eastern US and the southern states too. So this is something that's really important to me. I'm also a farm kid. I'm also human, so I eat. And therefore, we have to figure out how to make this all work with natural resources and farming and not point too many fingers at anybody. So I may have just given a little bit too much foreshadowing there, but I just wanted to make sure that we were all on the same page before I start this conversation. So if you follow the news and you happen to be aware of some of the things that have been going on in not only ag-related news, but also news that comes over with natural resources, dicamba has been a hot topic for several years now, since 2016, actually. So, and maybe even a few years before that, but there's been at least one murder that we know of related to these dicamba products. And that took place a number of years ago when a farmhand and a farmer encountered each other on a a back road over some damage on some bean plants, and next thing you know, things did not turn out so well for somebody. There's also been a number of lawsuits related to dicamba over the years, particularly in higher courts and federal courts, and there's been a couple of vacatures with labels and things like that. So it's been complicated from the court side over the years. There's been lots and lots of drift complaints since 2016, 2017 era, hundreds and hundreds per state in the Midwest. And it only seems to tail off when people kind of get tired of reporting the damage, not because there's necessarily less damage on the landscape. And then there's been some really big ones out there. The one big headline a few years ago was when a Missouri farmer, Bill Bader, won $265 million in a lawsuit against some big ag companies. I don't think he ended up with that much money, but the lawsuit originally was for that. But if you've seen anything recently, you've probably seen this headline, which says that the court vacated dicamba registrations recently. That happened just over a month ago. And while that headline looks really awesome at face value, it's actually far more complicated than those words would indicate. So we'll get into that towards the end of the presentation. And also what it means for this growing season when even though those labels were vacated on 3 particular dicamba products, the EPA is still allowing those to be sprayed this growing season. So we'll get into that here in a little bit. All right, so if you want to know more about this topic, there's some really great articles out there, opinion pieces especially. NPR did an interesting one called "A Drifting Weed Killer Puts Prize Trees at Risk." This is from 2018, and I still think it's a great read even now, but it was talking about the trees, the bald cypress around Reelfoot Lake and how they were injured by dicamba, several years ago. There's also a really interesting report. It's an advocacy piece put out by Prairie River Network and the Xerces Society. It's called Drifting Toward Disaster. And we have an internal working group that tackles issues like this. And I had that group, when it was my turn, I had them read this report. There's a lot of good information in here, especially if you'd like to learn about this issue in more in depth. So I encourage you to look this up. It's easily available online, and it's a good read. All right, so let's get into some of the history of particularly the dicamba issue, and then we'll approach the 2,4-D issue in a little while. But the dicamba issue, at least for me, really started in 2016. And I remember then, I wasn't the forest entomologist quite yet, but I was in the forest health program here at MDC, and my counterparts at the time were talking about this tree injury that had occurred on the Bader Peach Farm down in Campbell, Missouri, which is in the Missouri Boot Heel. And I remember thinking, well, that's really weird. There's all this injury, it must be they were just spraying too much on a windy day and it damaged these peach trees. I didn't think much of it. The applicator, I don't think was fined very much, maybe a couple $1,000s at the most. It seemed like, it was one of those things where it's like, well, too bad for Bill Bader, but the rest of the world can move on, right? But the next year, there was this article on June 12th in 2017 that MU posted on their email blast. And I remember looking at those pictures first. And of course, being in forest health, I am not too concerned about a Bradford pear, Callery pear dying. So, cheer on the death of that Callery pear right there. But I saw those tomatoes and I nearly had a heart attack because as a home gardener, I would be devastated if my tomatoes were sprayed accidentally by somebody or if they incurred some type of damage. And the more I read this article, the more I started to understand the implications of some new dicamba products that were hitting the market. And the main implication was that a product like dicamba that had never really been sprayed during the warm part of the growing season, so think May and June, was now legal to be sprayed during that time period. And from the way the article was written, it seemed like this could be a really bad thing for non-target trees and plants, for example, broadleaf trees and plants. And so for me, it was like, well, that's interesting. Maybe I should look a little bit more into this. And it was interesting to me because if you look at Missouri's landscape, there on the left, we have forest cover, a map generated by my agency. All the green area are places where there's supposedly trees, right? And if you look there on the right, while this map is not entirely complete, it seems, you can tell that the most treed area in Missouri is the part of the state where there's the least soybeans, to make total sense, right? And then the areas where, we have a little bit the more prairie type, if you will, that's where we see a lot of beans. And of course, down in the boot heel, we see a lot of soybeans planted in those landscapes. But there's trees within these agricultural landscapes, right? They live side by side, somewhat peacefully in most times, but here lately, maybe not so much. So I just want to remind everybody that the soybean acreage across the US, this was the map from 2022, there was an estimated 87,450,000 acres of beans that were planted that year. And the greater cropping area of the US is roughly about 200 million acres that are planted a year, about 80 to 90 million acres in beans, 80 to 90 million acres in corn, and then up to about 10 to 20 million acres of cotton. So this is a big portion of the US where these chemicals could easily be sprayed or legally widely used on soybeans. And also there's use on cotton and corn to some extent too. So we're looking at roughly 200 million acres of the US where these chemicals could be applied. Now, these chemicals have actually been applied for a number of years in the US, but the timing and there's some reasons for when we apply them and why that have changed in the in recent years. But I want to talk about what dicamba and 2,4-D are before I get into that. So these two chemicals are part of the plant growth regulator category, group 4 on the chemical sheet. And what they do simplistically is they increase the plant growth rate, and that causes a small 4-inch weed basically to outgrow its nutrient supply and die. So these are referred to as the auxin chemicals because dicamba and 2,4-D stimulate that auxin production. They stimulate that growth of a small plant. But what do they do to things that are a little bit longer lived, like our prairie forbs or trees? We're not entirely sure about that. What we do know is that dicamba has actually been around for a long time, hence the old chemicals. Dicamba since 1967 and 2,4-D since 1945. And in general, these have typically been sprayed in the early part of the growing season and usually in cornfields. Okay, and not any time when there were sensitive species that were leafed out, particularly soybean, because we know this is very damaging on soy, but also sensitive things, including many of our tree species. So when it's sprayed in that early part of the growing season, when the weather is very cool, we see very low volatility coming from these chemicals. And if you don't know what volatility is, trust me, in about 5 minutes, I promise you will. So there is widespread usage of these chemicals, not only in row crop, but also on lawns. A lot of what we see in urban lawn care or just, a homeowner lawn care is dicamba and or 2,4-D, among a couple other chemicals. Also, we see this in range use, excuse me, and with right-of-way use. So these two chemicals, while they may not be ones that you think of as being widely used, they actually are some of the most widely used products in the US. And there has been renewed interest in just looking at different types of herbicides because we have so many resistant weeds, particularly glyphosate or Roundup resistant weeds in our croplands across the country now. So that's part of the reason why these old chemicals have kind of been brought out of the closet and used in a way that they weren't traditionally used. So just looking at dicamba, because there's been more information come out in recent years on the sensitivity of plants to dicamba, uh, when we're just looking at dicamba, it's impressive to me how little is actually needed to cause injury on these really sensitive plants. So a lot of what I show you will be soy because obviously there's been more research done on soy than on natural resources like trees and forbs, but it takes 1/20,000th of a standard use rate of dicamba to cause visually noticeable injury on soybean. And if you look down there, that's actually a peach branch right there. That's 1/20th the use rate of standard use rate on a peach tree. So it actually takes very little of this chemical to cause quite a bit of damage on sensitive plants. So I just found this recently. I thought it was a really good illustration. That red dot right there is that droplet contains 0.044 milliliters, which is equivalent to 0.0154 grams of active ingredient, dicamba, in a product, one of these low volatility dicamba products called Extendamax. This amount is enough to cause 5% visual injury on a whole acre of soybeans. So, if that helps put it into perspective, how little can cause visual damage, for me, it definitely helped to see that red dot right there. So let's talk about herbicide movement. Okay, for me, this was an eye opener, and I just keep having epiphanies about this over the last several months. Even I learned new ways in which herbicide can move because I thought kind of naively that the only thing that would make herbicide move was basically direct particle drift. Okay, so that's when the sprayer is going a little bit too fast in the field or the wind's blowing a little bit too hard that day. And next thing you know, those spray droplets that were supposed to land in a certain place are whisked away by the wind and they end up in the fence row next to the field. So that's what we refer to as particle drift. Anybody who's ever sprayed herbicide has probably been concerned about that at some point in time. Another mode of off-target movement, which we've learned through the dicamba situation, is tank contamination. Now, tank contamination is when one product is used in a tank and then you don't thoroughly rinse and clean out that tank before you mix something new, and then you risk some of the residue from the original mixture being present in the second part or when you spray the next tank. So that's definitely something to keep in mind, even on your own property, if you use any kind of herbicide, to rinse at least 3 times in between tanks, different mixes, so that you don't cross contaminate. So tank contamination is actually something that's very common in the ag world, and it was something that a lot of the applicators had to realize when they started using these new dicamba products as they were switching between fields. Another way that herbicides move is through temperature inversions. And temperature inversions, as you can see by my little GIF right there that I did not create, someone else did. A temperature inversion is when a layer of warm air forms and it traps a colder layer of air beneath it. And these tend to set up during many of the summer nights in Missouri and in the Midwest in general. These are pretty common. And so for me, it's when I'm driving down I-70, at 6 a.m. on a June morning, and I see kind of that fog setting in into the lower areas in a field, or sometimes you'll see it just above a field. That's that inversion layer. So something we've all seen, but it's pretty common. Now, the way herbicide moves in an inversion layer is that if an applicator is spraying late in the afternoon and that inversion layer has already set in, some droplets from the sprayer may actually become trapped in that inversion layer. And then depending on where the wind moves or that air mass moves over the course of the evening before it dissipates in the morning, those fine, very fine spray droplets can actually end up in that layer moved about the landscape. So another thing I've recently learned about is erosion and wet loading, and that has to do with precipitation. So some herbicides, may tightly bond to dust or soil particles, and then they end up eroding through wind movement, and those may end up in the atmosphere. And then eventually they join some kind of precipitation molecule, and then that whole thing comes back down to earth. So that's one way that herbicide can move very long distances and contribute to atmospheric loading of some of these chemicals too. And then the last way that this is the way that I'm really concerned about is this volatility or vapor drift. And this is the conversion from a liquid to a vapor after on target application. And so volatility is usually due to the inherent chemical properties of the chemical. So some chemicals they don't have very high vapor pressure. So they're actually not very prone to volatility. Something like glyphosate or glufosinate, these two are not prone to volatility. Whereas ones with a little bit higher vapor pressure, such as 2,4-D, dicamba, there's several others, they have that higher vapor pressure and they're more prone to turning into a gas after they've been appropriately applied. So once it's a gas, it can move around, right? It can move into those inversion layers, and then it can be moved across the landscape, kind of close to Earth's surface. Or if it's a gas, it may rise into the atmosphere and contribute to atmospheric loading of these chemicals. And that actually is probably one of the bigger concerns that we have. So I really want you to understand what volatilization is, because I find that this is really, really hard for us humans to wrap our minds around. It's not just this idea of direct drift. It is volatilization when these chemicals have been applied appropriately, and then for whatever chemical reasons, they turn into a vapor and then they move away from the site that they were applied. And this is often not because the applicator did anything wrong or didn't follow the directions appropriately. It's because of the chemical properties of that herbicide. And so for me, it's a guess what you're breathing, because this is in the air that we breathe. I mean, if the trees are getting hit, then we also know that we're probably breathing a lot of this stuff. And, as a mother of two young kids, this is something I'm worried about, not only for my sake, but for the sake of my children. And I see it in my own yard. So it is definitely a concern for me. So dicamba is volatile. Okay. We know that it has a higher vapor pressure, and that volatility with dicamba is pretty common above 85 degrees Fahrenheit when there's high humidity, when dicamba hits leaves or really acidic soil, or when it's tank mixed with something like glyphosate, because that lowers the pH of the tank mix. So really, all of these things right here contribute to dicamba's volatility, and you can pretty much check off all of these as being present when this stuff is sprayed in May and June in Missouri. In fact, a couple weeks ago, we had almost 85 degrees in February. So, we're seeing these warmer temperatures, and I think that's contributing to some of this volatility. Another thing about dicamba is that volatility is not just a risk for, 24 hours or 12 hours after application. It's a risk for up to 96 hours post application. So this product has long since dried, and yet it is still possible that it will volatilize and walk off or leave the field that it was applied in. And then does it move, to the next household over? Does it move 5 miles down the road, more, less, 10 miles? Does it go up into the atmosphere and come back down in rainwater 75 miles away? We don't know, because it's impossible to trace, quite honestly. It's not like Farmer Smith's dicamba volatilizes purple and Farmer Joe's, his volatilizes green, and then we can kind of track it from where it came. That's not how this works. It's far harder to trace this stuff than it seems. And it's really easy to miss dicamba because plants can actually metabolize it, it seems, pretty quickly. So if you aren't taking residue samples on plants within a fairly short period of time, like within a couple weeks after they've been contacted by the dicamba particles, then you might entirely miss that dicamba. It may not show up in a chemical residue test. So now I want to get back to 2,4-D. It's considered quite a bit less volatile than its close cousin dicamba, but we see it in almost all of the Illinois and Missouri tree samples that we've taken over the last several years. So there must be some level of volatility to it that is just not really being understood from basically the side of the EPA. It seems like dicamba or 2,4-D is probably contributing quite a bit to atmospheric loading and wet deposition. Mostly because of how often we see it in those samples. And then we do know that dicamba or 2,4-D is easier to pick up in our samples because it seems like it's held longer in the meristems of a growing plant or tree. and it doesn't seem like it's processed quite as quickly as the dicamba. So that could be part of the reason that we pick up more 2,4-D. It's just because the plants hold it longer. So just to reiterate this point, drift happens while the sprayer is still in the field. Okay, this is your direct particle drift. But volatility occurs after the sprayer has left and up to 96 hours after the sprayer has left. Okay, so the problem with this is that it can't be controlled. You know, if the applicator sprayed dicamba on a 60-degree day, did everything correctly on, the 30-page label, followed all the rules. If the next day it turns into 85 or 90 degrees, which we know can happen in Missouri, that dicamba may still volatilize for up to 4 days after that sprayer has left. So that's why these chemicals are a problem. So to summarize at this point, I've had to skip a lot of the history of this issue and some of the other details. But the main thing that you need to know at this point is that there's been lots of attempts since 2017 to control dicamba. These low volatility dicamba products, there's been additions that need to be made to the tank mixes. There's been cutoff dates, saying you can't apply this product past June 12th or June 30th or whatever the dates are for different states. There's been a ton of required applicator training and so many label restrictions put on the applicators that I think it was a few years ago, they looked in Indiana and it showed that there was only about a 40-hour time frame in the whole growing season where this one location you could follow the dicamba label to the T. So these are very restrictive labels. And despite all of this, we still see injury at a pretty broad level across the ag landscapes of several of the Midwestern states. And it's also interesting to me that everybody's going after dicamba, but nobody seems that concerned about 2,4-D. It gets mentioned here and there, but in general, it's not something that is being sued for right now for the vacatur of these products. And so that's a little alarming to me because we see so much 2,4-D show up in our samples. But most people agree the injury is drastically underreported, especially on trees and flowering plants. So this one is one that I found really interesting in 2018. I never really paid attention to trees, but in the last 2 or 3 years, I've actually started looking at trees in people's yards and everything. And it's amazing once you start looking what you see. And I hope after you see some of these photos today that this will be kind of a light bulb moment for you as well if you live in these ag mosaic areas, or even if you live in an urban area where I see a lot of this damage very commonly. So let's look at it from a tree perspective. What do we know about trees? I circled the pesticides part there on the North Carolina Forest Service tree stress agent diagram. It seems like it's a very small part of all the things that can happen to trees, right? But it's actually a pretty major part too. So what we know about these two chemicals and injury on trees is really nothing, unfortunately. We don't have hardly any long-term data on how mature trees just growing out and about in the landscape handle this kind of injury, not just once, but multi exposure data for the same season. So one tree may get hit 12 different times in a growing season, or 15 different times, or maybe every day for 6 weeks straight. But we don't know how that tree is going to handle that kind of damage over the course of one season, let alone multiple years. And there's been some ideas that 3 to 5 years of exposure, especially extreme exposure on these trees, could cause death. I think that in general, what we're seeing in Missouri is that this level of damage is probably increasing tree stress. And there's a lot of stress on trees right now. I track a lot of the drought monitoring and the rain. We get a lot of rain early on and we don't get any more rain for the rest of the year. That's stressful for trees. Like there's just a lot going on with trees right now from a stress side. So this is one more thing, the straw that broke the camel's back is what I'm concerned about long term when it comes to trees. But at least we can see dead trees, right? So that's what I say when I go to the boot heel. I'm looking for dead trees and they're going to stay standing for a while. And then I'm trying to figure out why they died. When it comes to some of our prairie plants, our forbs, especially that could potentially be damaged by this stuff. We don't see skeletons, if you will, with our forbs. They just disappear, and we might never know that they were ever there or that they were injured and gone. So visible damage varies when it comes to trees. In my experience, it seems to depend on the species and sometimes on that individual tree's health or, some other maybe genetic component. Also, the damage varies according to exposure intensity, the frequency, how many times that tree got hit, and when that tree got hit. Seems like earlier in the growing season, if those leaves are expanding and they get hit by herbicide, then they're going to really show an extreme visual symptom of herbicide injury versus if they get hit later after they've already expanded and sort of matured for the growing season. And then weather patterns also change how we see visible damage across the landscape. If we have a really wet year and farmers can't get into the field till late, then we have not seen as much tree injury in those years in the past. Common symptoms develop within 7 to 21 days, particularly on a volatility hit with a tree. Now, if you had a direct drift issue, then you might see symptoms sooner than this. But when it's volatility, when it's a gas floating through the air contacting tree leaves, it takes a little while for some of the symptoms to occur. And so you often see cupped, twisted, or elongated leaves, and you may see injury that happens throughout the entire canopy, or it can be patchy. And I'll show you why in just a minute. And you may only see injury on the older or the newer growth, because sometimes that when that herbicide contacts that growing twig will dictate which leaves look symptomatic and which don't. So here's what I was saying with the foggy fingers. These are temperature inversions, obviously not Missouri, so I apologize for that. But we see different patterns emerge in the canopies of a single tree sometimes. One of my study sites has these amazing white oak. They often have giant poison ivy vines growing up them. And poison ivy seems to be very sensitive to these herbicides. And you'll see one part of the vine that's totally normal, another part that is just entirely messed up, and then another part that's kind of somewhere in between. And so for me, I envision these foggy inversion layers, these foggy fingers settling over these trees and over these landscapes. And that's how you see a variety of injury patterns across, maybe one property, because not all the trees are getting, the herbicide volatility hanging on them in the same concentration for the same amount of time. So if you see various patterns like that, that's completely normal with this issue. So what does this type of injury look like? You have probably seen it before, but you maybe didn't know what you were looking at. People often attribute this sort of injury to insects, particularly sucking insects that might feed along the edge of a leaf and then cause it to curl like that. But in a lot of cases, I do look for insects to make sure that's not what's going on some of these damaged trees. But in a lot of cases, it is herbicide that we're dealing with. So this picture of a redbud is pretty typical of dicamba damage on redbud. You can see that those leaves are downward cupped. Sometimes you see upward cupped leaves. I suspect that's probably 2,4-D damage. But redbud's really the canary in the coal mine. Most redbuds across Missouri, even in a town setting, especially in an urban setting, are damaged like this. This is very common. So this was a very low parts per billion, 3.43. And this was a July sample. So if I'd taken this sample 6 weeks earlier, I suspect I would have gotten quite a bit more residue, and that, would have given me a better idea of how much residue it actually takes to cause this level of damage. So this is on a red oak group species. You can see that it is also cupped downward, much like that redbud. These two trees were actually very close together. Again, a very low amount of dicamba residue came back on the test. But this was a late sample for us. So something that we proved dicamba was there, but not at a very high rate. Here we have a huge sycamore. This one actually lives next to the McBain bur oak, if any of you have been there. A little bit higher amount of dicamba on this tree, and that means it also was probably on that poor bur oak down in the bottoms. But you can see 56.4 parts per billion in early July. And that tree, people say that with sycamore and dicamba damage, you could flip it over and pour a glass of wine in it. That's how much damage happens, how much cupping happens on a sycamore with dicamba. Here's bald cypress, a pretty light hit in early part of July that we recorded. And then later in the growing season, we took another test and it tested, absolutely zero residue at that point. But obviously, dicamba or bald cypress, the normal leaves there on the left versus how it looks long and strappy with dicamba damage. Here's silver maple. To me, that silver maple looked honestly quite normal. It did have a scale infestation, which can kind of, mess up the leaf pattern a little bit. But when we tested it in June, it had a whole lot of dicamba on it. That was one of our highest residue tests that we've ever had. And here we have a white oak that shows a whole lot of injury patterns going on. You can see that at different points in time as that twig was growing for the year and new leaves were popping out, I think different chemicals were in the air at the time and were causing different patterns, injury patterns. So to me, this suggests that there was multiple exposures over the course of probably several weeks as this tree was leafing out. And this white oak right here, I think it was same tree or tree next to the last one. This very extreme injury, and again, two different injury patterns there, uh, means that this was likely happening during leaf expansion. This wasn't something that happened after the leaves had fully expanded normally, and then the leaves do this. That's not what occurs. This has to be occurring when the leaves are expanding. So here's a willow oak. I call this look flash fry. The whole tree looked like the leaves on the right, and the leaves on the left we got from a different tree. But this was extreme exposure to some chemicals. And I've also noticed that with dicamba and 2,4-D especially, I can walk up to an oak tree, pull the branch down to inspect it, and the whole branch just breaks off in my hand. There's something going on with the wood in these exposed trees. I don't quite know what yet, if it's messing somehow with the lignin or what's happening there at a cellular level, but it's really easy to break these branches off of trees. They just pop off. So here's some confirmed 2,4-D injury in Illinois. What's the long-term health of a tree that looks like this every year? I can't imagine that it's good. And actually in Illinois, they're seeing trees die, and they think it's probably largely due to herbicide issues. I wouldn't go so far as to say that that's what we're seeing here in Missouri yet, but I also think that this is cumulative stress adding up over time, and that we could, in some areas, get to this point in the coming years, especially if we have a really bad drought in our future. So if the only thing at risk were soybean fields, then let ag do what it wants. But when you start damaging native plants and trees, to me, that's unacceptable. And every time I read this quote, I just kind of get fired up about this topic, because this part of herbicide is unacceptable. The idea that these chemicals are able to just volatilize and move across the landscape and damage other things, like, to me, that's just amazing that this is allowed to occur in 2024. So it's amazing that it was allowed to occur now, but even 8 years ago, or 6 years ago, excuse me, this was something that we thought, well, we need to start doing something about this. So we started an herbicide injury project in 2018 with some little bit of money from the Forest Service, and several of us states participated in it. And our initial goal was just to link the symptoms that we were seeing on trees to the amount of residue that it took to cause those symptoms. And we were doing our testing with South Dakota Agricultural Laboratories in Brookings. And then we were taking pictures of all these trees. And what we learned was that this is way easier said than done. This was actually a really difficult project. And we learned a lot those first few years because it was really hard to sample at the right time. We didn't realize that we had to really get on our sampling early in the growing season. So, this tree right here, it doesn't actually look so bad, right? This sample was taken in June, late June of a year where it was really late that farmers were getting into the field due to a whole lot of rain that early part of the growing season. And this tree right here tested pretty high for both dicamba and 2,4-D. but it really did not look that bad. We were just taking a sample to take one at that point. So what we learned is that earlier sampling means less symptom development of these trees, with herbicide in respect to herbicide residue. So the sycamore right here, the sample was taken at the end of August, and this tree looked absolutely terrible. And we figured it would come back for more chemicals, but no 2,4-D detected, and just a little bit of dicamba overall. So what we learned here is that the later we sample, the less symptom development, or the more symptom development, but the less herbicide residue. And so that was kind of a critical thing that helped us to learn that, these samples really need to be taken pretty early on. And keep that in mind if you are experiencing some kind of damage like this on your own property. So another part of this herbicide injury project, the following year was to look for different herbicides. We had a little bit more money. We could test for few more things, and well, surprise, there were actually more herbicides than just dicamba and 2,4-D, but we still couldn't test for everything. So we did test for an extra couple of plant growth regulator group 4 herbicides, and we found quinclorac. This is one I'd never even heard of. Apparently, it's used in crabgrass control in urban settings, but it's also used in rice. And if you've ever been to the Boot Heel, then you know Missouri does grow a bit of rice down there. So I think that's how quinclorac was getting into our samples. So of the 10 samples that we took in 2019, all 10 had dicamba. 8 of them also had 2,4-D, and 7 also had quinclorac, but we didn't find any triclopyr that year. So right here, you can see just kind of a hot mess of herbicides that are occurring that we were able to capture on this bald cypress branch. So because we didn't screen for any other groups of herbicides, what else are we missing? And that's kind of an interesting point for me moving into the future, looking at expanding what we're trying to find as far as herbicides go on trees and plants. So that bald cypress was taken from a city park in the tiny town of Bernie down in the Boot Heel. And as you can see in this area, I mean, trees really only occur in a town in an urban setting. But the trees are really important to the people there. And this park is such a great place to look at different kinds of tree injury because they have a really wide variety of tree species planted there. And I was there one time, taking tree samples and photographing them, and this little girl and her grandma drove by, and they stopped, and they asked me what I was doing, and I told them that I was looking out for the trees. I was trying to figure out what was going on with them, and they were like, "Oh, that's great! Just that's so good that you're looking out for the trees." And then they drove off, and I felt kind of sad because not only is it the trees that are impacted in their town, but it's also all the people there that they're breathing all of this, and that's pretty unfortunate. So this overcup oak right here, it tested positive for 3 different herbicides, dicamba, 2,4-D, and quinclorac. And really, it's not showing many signs of this at all. It looks pretty good, right? But what bothers me about that tree is that it is 2,500 feet through the woods from a field edge in the middle of a really important part of the Boot Heel, Big Cane Conservation Area, Carmichael State Forest, All Red Lake Natural Area, and then a big chunk of forest down in Arkansas there. To me, this is a very important island of habitat for migrating birds, maybe some other species that are really restricted in this highly agricultural setting. And so it bothers me that I can pick up 3 different herbicides in the middle of the woods like this and not truly know how they got there. Was it volatility? Was it rain? I don't know. So another part of the project I've been working on is 76 Conservation Area. This area is in Perry County, located along the Mississippi River. Beautiful conservation area. Perry County is a beautiful county as well. Grows some of the nicest trees that we have here in Missouri, thanks to really great soil and just awesome place to go visit. I would encourage you to do so. However, it is also in an ag landscape. So there's a lot of agriculture in Perry County, even though it's super hilly. This area is very hilly, but again, highly productive soils, forests, definitely high value forests spread among lots of agriculture. And then if you look on the Illinois side, you can see just how much row crop is going on just right across the river. So what we've done at this location is to mark 20 trees. We visit them in the early part of the growing season several times to kind of keep track of them every week or so. We've also done a drone flight at some point in the summer to see how they look from above. And we go back and visit them in the late fall to make sure that they're still alive and kind of see how their injury level ended up for the whole summer. And we've collected some tree cores there. And while we have a very limited study size, especially on our tree cores, what we think is happening is that there's really reduced growth in these super high value white oaks if they are hit by herbicide at a pretty high level. So, a severely injured tree, it's going to shut down its growth the way it would in a severe drought, is what it looks like. So we use this rating scale over there. This is taken from Prairie Rivers Network, a report that they did and published, I think, back in late 2019. We try to use the same rating scale that they do so that we're as consistent as we can be across the states. And as you can see, there's various levels there of herbicide injury. A lot of times in the early part of the growing season, our trees look, 1 to 2, fairly normal, and then they suddenly become a 3 or 4. But we've had trees as high as 7 to 8 occur on our 76 conservation area site. So unfortunately, it is an herbicide party there too. And in 2021, we detected 3 different herbicides, 2,4-D, Dicamba, and MCPP, which is another group 4 herbicide that can be volatile and would have showed up there probably through volatility or possibly through rainwater. We don't know exactly, but it didn't show up here because of direct drift. We're pretty confident of that. So what we see with this site, it's not only the oaks that are injured, it's also the blueberry. It can be curled. It usually doesn't produce berries there. Tulip poplar, hickory, several of the other species that we see there are often injured. So this white oak canopy here, that picture was taken in late August. A white oak, you should not be able to see sky through a healthy, mature white oak canopy. This tree was so injured that its leaves were just unrecognizable. We call this Medusa, is the term we've come up with. It's the worst of the leaves. Like I said, they are almost completely unrecognizable. And those leaves that are that damaged, they can't be functioning properly, right? I mean, some of you may have a plant physiology background or knowledge of how plants work, but with a tree, it's kind of simple. The roots take up the water, and it comes up through, the trunk, and it's all related to the leaves and how they're pulling water up through that system. But when those leaves are so damaged and they're super leathery, I can't imagine that the leaves and the tree itself is totally functioning properly. So to me, from the tree health side, it probably indicates that there's, potential for root rot and secondary issues to come along and take these trees out. And that's my biggest concern, is that while this herbicide may not be a primary cause of death, it is certainly contributing to the stress and the downfall, the decline of these trees. So this right here is, you'll have to kind of zoom in, focus a little bit on what you're seeing here, but it's a branch that's coming out towards you. And I've pointed out, you see that little acorn there? This is a white oak branch. That tiny acorn, I blew it up just a little bit, is severely damaged. It doesn't look right. I put what a natural healthy acorn for a white oak looks like up there in the top right corner. And what we're seeing in some of these areas where there's severe injury is that there's either no acorns or they're really ugly and they end up being aborted. They don't make it all the way to the end of the growing season. I doubt that they're viable. How could they possibly be viable? Which means they're not going to turn into a tree. They're not going to be a snack for a squirrel. They're just pretty much useless if they're even able to form. We also see hardly any insect feeding on these really damaged leaves. And I hope a lot of you were able to watch Dr. Ptolemy's talk last week, where, oaks are the keystone for our insect species, for birds. And without insects eating on our oak trees, we're going to see population declines, all the way up the food chain. And so this is pretty bothersome to me, that I hardly see any insect feeding, galling, anything on these leaves that are injured. And reduced leaf litter. You know, these leaves are not functioning the same way that a nice flat white oak leaf functions when it falls to the forest floor. Okay, so in some of these areas where these trees are severely injured, you know, these leaves are not staying. I just don't think they stay in the system as long. I don't know if they rot faster or not, but we definitely see a lot of bare area at 76 conservation area, and part of that is sort of a natural thing with the nutrient cycling there, but part of it is cause for concern of erosion and things like that. Erosion. One of the things I forgot to mention when it comes to the insect feeding, when it comes to caterpillars in particular, they can be really sensitive to what they're eating. So even if what they are the leaf they're eating doesn't have an insecticide on it that might kill them, if they're sensing a chemical that is not in their preferred, you know, it's something that just says, ooh, this is yucky, you probably shouldn't eat this, that could be happening with these residues of dicamba and 2,4-D and other herbicides. So that's a big concern for me as well. And then, of course, that reduced annual growth that I mentioned before, you know, we could economically quantify that if we did more coring and were able to make a model with that. So timing matters is one of the other things that we've learned at this site with our frequent early growing season visits. It seems like phenology might be part of the story, and climate change could be changing phenology on our trees. So phenology is, you know, basically when they start to leaf out in the early part of the growing season, and when things get rolling for the natural world after winter. So I had to put this in here. I do not watch It's Always Sunny in Philadelphia. It's not my show. Haven't watched it before. However, I can relate to the look on this guy's face when it comes to this herbicide stuff. I mean, this is me in my office on a daily basis trying to figure out how all of this links together and how I'm gonna stop it, we're gonna stop it, how we're gonna fix this, because this really matters that much to me, and I think it should matter to all of us as well. So, a couple of points I wanna make here. Tree injury, it appears, is worse when damage occurs in the early part of the growing season. And these 4 words here are actually pretty important. This is like a mind-blowing breakthrough for me in the last 3 months or so, because I've just been trying to figure this out for several years now. It's like, okay, tree injury, what's going on here? What's happening? There's got to be there's got to be more to this puzzle. And then it finally dawned on me that the cover crops that we're putting out there as conservation practices nowadays, you know, those crops that are planted after harvest in the fall, and then also what's happening with spring burn down, as far as when farmers get in the field and kill those initial winter annual weeds, both of these activities are potentially using high volatility dicamba and 2,4-D products. Okay, so there's the low volatility products that are used during May and June, but there's also a whole bunch of high volatility products that are older versions of dicamba and 2,4-D that are widely used because they're super cheap. And when farmers use them in, say, March or early April, it traditionally hasn't been a problem because, you know, based off of climate and weather, our trees and plants aren't out at that time. However, with climate change and earlier bud break and the potential for late spring freezes and then trees to have to relief, this all puts trees at risk for damage during that early part of the growing season, that early spraying. So while we've been blaming a lot of the tree injury on these May and June sprays, I think what's actually happening is that it's the March and April, particularly the April sprays and the early May sprays, that could be causing the most problems for trees. So I put a how do we fix it in here because this one to me, like we can actually do something about this. I think that farmers should consider moving to non-volatile herbicides. There's so many herbicides on the market, right? And not all of them are volatile. And there's hopefully some cheap ones that could be used in the early part of the growing season that wouldn't then cause further damage on natural resources, particularly trees. Or, and hear me out, this sounds terrible, but before some of these low volatility dicamba products were pulled, the labels were vacated recently. I actually wanted to suggest to the soybean growers that they use more low volatility product, but they use it in the early part of the growing season, because that would mean that there's just less volatility that's occurring during April. And they traditionally don't use that stuff then because it is way more expensive than the old versions of dicamba and 2,4-D. But that would be a great time to test it out and see if my theory is correct here. And then glyphosate, Roundup, I know a lot of us have like really strong feelings when it comes to that, particularly in our food supply. But glyphosate doesn't volatilize. And if we could get away with using some of that, maybe it's not so bad. So here's just a little bit of information on cumulative growing degree days to kind of support my point here. Right now, we're really warming up way earlier than we usually do. We're about a month ahead in most of the state. But what's going on is that even statistically, we're seeing our last frost date about 6 days earlier, sometime in the early to mid part of April. It used to be about April 15th. Now it's somewhere around April 5th. And then we also have been getting these late spring freezes due to kind of atmospheric instability thanks to climate change. And so not only are we seeing earlier leaf out, which could put trees at risk for herbicide injury, but then if the trees do get damaged by that spring freeze, then when they try to leaf out again in the later part of April or early May, then they're exposed to a whole bunch of herbicide then as well. So kind of a double whammy here with that. So forb injury appears to be more problematic with the later season sprays. And tree injury, as I explained, it's less probably as the leaves start to harden off for the year, for the growing season. But that forb injury, those forbs are just getting started in May and June. Some of them don't even do their thing until July or later. And so with these over-the-top dicamba and 2,4-D products that are sprayed into the later part of the growing season, any minute volatility that comes from those could be more damaging to these forbs. And I didn't include a solution here because I'm not sure what the solution is besides these products being entirely pulled from the market. But what we do know is that from a research perspective, dicamba disrupts flowering phenology, decreases plant growth, reduces flower production. 2,4-D affects nectar production. And so there's a lot of concern for the overall seed production. So this is affecting our pollinators, potentially affecting our birds. So definitely an ecosystem issue here too. So forbs are injured. That rose mallow there looked terrible. I don't know if it ever bloomed. A lot of them, the flowers just completely abort. And I saw it for myself last fall. I was late September. I was at Holly Ridge Conservation Area in the Boot Heel, and I saw 2,500 feet in from a field edge into the woods. I saw damage on native goldenrod species as well as on farkleberry. So yeah, it was drifting through the woods somehow or getting there through rainwater. And of course, we have some really rare habitats that are scattered among our highly agricultural landscapes, whether it be just our regular old beautiful prairies or rare sand prairies like this. They typically live next to crop fields, and this could be really devastating. Probably is being devastated by these chemicals. So what's next? Dicamba and 2,4-D are not going away despite any recent headlines you may have seen. It was only the 3 low volatility dicamba products that had their label vacated by a recent federal court decision. And those low volatility products are really the only ones that we should probably even consider using, but now they've been pulled. However, there is an existing stocks order that's been released. So, those will be used. Whatever is already in the supply chain will be utilized this growing season. But I want to remind everybody that there are actually hundreds of dicamba and 2,4-D products that are registered in Missouri, and very few of them are actually classified as low volatility. So in 2027, this is the scariest thing for me. There's a new generation of soybean seeds that are going to be released, and these seeds will currently the way it is seeds are resistant or tolerant to dicamba or 2,4-D and some other things, but not both dicamba and 2,4-D. So 2,4-D sprayed on dicamba beans injures it, and dicamba sprayed on 2,4-D beans injures it, or volatility. So there's some issue, ag is still dealing with all of that injury that's out there on the landscape. But in 2027, we'll have seeds that are dicamba and 2,4-D tolerant. So it means there's really not going to be any more soybean injury out there. And that's alarming, because if ag doesn't see this as a problem anymore, I don't know how us natural resource folks are going to fix it. So what's the future work? For me, I'm long-term tracking a lot of trees to see if they die. We've established some permanent plots that we're going to visit annually for the next, many years. I got 20 years left before I can retire, so at least for 20 years. And we need to be doing some more tracking of things, but as far as timing of exposure and rain and air, but this is super difficult and super expensive work. So we know timing's is important, and it could be the solution to working together with ag to find the right solution for this. Ideally, we'd look at air monitoring, but that's just really out of the price range and out of my abilities. We are looking at doing a pilot on rain and soil for wet deposition this year, and also for looking at what else is out there besides dicamba and 2,4-D and other group 4 herbicides. Are there other herbicides we should be considering? And then how is this affecting the ecosystem? If you take nothing else from this talk besides the fact that this is a complicated issue. It's very alarming in a lot of ways. It's not everywhere, but it is widespread across the state. And it could be having cumulative ecosystem impacts. So that's the most concerning thing. Just keep that in mind. We see this limited insect feeding. We're concerned about soil and roots. Small ground flora plants that are exposed to this we wouldn't notice if they dropped out of the system, right? And then, of course, tree regeneration could be an issue, as well as tree death. And then there's the need for the outreach campaign. I'm not that brave. That's not my platform as a conservation department employee, but this is something that probably needs to be done. I think the more people we get on board with this, the better we're going to move the needle on this issue. So what's going to happen in 2024? Possibly a very bad year for herbicide injury. And why? Well, that's because spring weather seems to influence the amount of injury we see on trees. Warm and dry could mean that the trees are leafing out earlier and spraying is occurring earlier. And so all of this is going to coincide in kind of a bad situation. If we do end up having that late freeze that knocks the first set of leaves off the trees, then they'll reflush when there's still lots of spray volatility in the air. And that's a very stressful thing for them. And so, it just makes them more susceptible to other things. And then that existing stocks order for low volatility products. These products could be in short supply. And I hate to say it because, I don't want to blame the farmers on this, but there could be that temptation to use those older high volatility dicamba products because they know they have the seed technology. And so there could be more volatility on the landscape. But please don't blame the farmers. This is more of a product blaming than anything. So what can you do about herbicide injury? Well, be very careful what you spray in your own yard. Read the labels very thoroughly. You can find any label PDF version on Google, and you can read it in big type instead of mouse type, like what's on the label on the bottle. So the first thing you can do is just not have more herbicide injury in your own yard. And if you suspect that your property has been hit by herbicide, whether it be volatility or you saw the neighbor spray something and it damaged your trees, you need to make notes on the date and the event. Okay. Take pictures of the damage you noticed that first day and then every day or every 3 days over the course of many weeks, if you can. Collect at least a 1-gallon bag of plant material, wrap it in a paper towel and freeze it. Once you freeze it, then that herbicide residue is not going anywhere, and you can test that a year later and still know what was on that plant. Visit with your neighbor, especially if you saw this happen, but you kind of got to be careful because in a lot of cases, I think people want to blame their nearest neighbor for the injury in their yard, but it may not have been that person at all. Remember I said these herbicides, this volatility can travel a number of miles. So just be very careful with that. And report it to the Missouri Department of Ag. They have a web page for that. And usually they'll send out an inspector, but it could be a long time. And so that's why your pictures and your residue samples in the freezer are very important. Please file official reports with the Department of Ag because eventually the EPA will be aware of these reports. This is important. So once you start looking, it's everywhere. Herbicide injury is not just dicamba and 2,4-D. It's not just near ag fields. We see it all over the place. It's probably 30% of the issues I deal with tree health. It's very pervasive these days. I see it on conservation areas. caused sometimes accidentally by our own staff, sometimes by permitting farmers. But it's common in natural areas. It's common in, not natural areas. And whatever it is on this tree, I never could figure it out. I couldn't even identify the species at that point. This kind of damage cannot be good for long-term tree health. It just can't. And us homeowners have done a number on our trees too. Lots of herbicide use. It seems to be increasing in lawn settings. Please don't use herbicides around your trees, no matter what. It's just not worth the risk. Including this poor little cabin here, Weekend Getaway, 5 years of a product called Barrier that has imazapyr, 2,4-D, and dicamba, as well as a couple others. It will kill your trees eventually. Trees are giant broadleaf weeds, so keep that in mind when you're using any kind of herbicide around them. So with that, I am finished and I'm ready to take questions.
And you have quite a lot of them, Robbie. Thank you so
Ruh-roh.
much.
You're welcome. I can stop sharing.
Please. Thanks. I was seeing myself very big. Lots of questions, and thank you. I mean, it's really upsetting, seriously, even to us folks that, learn about really upsetting things all the time, but incredibly informative and incredibly eye-opening. And there was some comments in the chat to that very end. So someone asks about the actual process. So what's the process for testing for residues? Is there a panel that gets run, or are you testing for particular agents based on the patterns?
Yep, that's a really good question. And this is the part that this is why this work is so complicated and so expensive. So if there's a few labs across the country that test samples, probably more than I even realized. The one I use in South Dakota, they have a menu on their website, and they usually test for herbicides by group. And there's, almost 24 groups of herbicides out there. And each group has a certain number of chemicals within it that they'll test for. For example, the group 4, I think there's 13 or 17 chemicals they'll test for, and it's about $250. So just to test for group 4 is $250. If I also wanted to see if there was glyphosate or glufosinate on those leaves, it cost another $150 each. And so when you start trying to figure out the sum total of what herbicides could be on a plant, it's astronomically expensive. We can't just run a sample and come back with, the results of, oh yeah, we picked up all these things. You actually have to say, I want to see if this is here, but that may not be the full story. So that just contributes to this being a more complex issue than we realize.
Someone asks about, is there anything we can do when we're out there looking and thinking about the things that you showed us? Is there anything we can do to help the trees that show damage? Watering them?
Yeah, that's a good question. So I'm glad you brought that up, because what I'm noticing is that trees that are hit by dicamba or 2,4-D through volatility or maybe through rainwater, those trees, they shake that off, and the next year they leaf out normally. Okay, so that's good news. If this is a yard tree and you could water it, that'd be great. 10 gallons of water per inch of trunk diameter. Don't overwater it, but water it 10 gallons per inch of trunk diameter every 2 to 3 weeks during a drought. So yeah, watering is great. That's really the only thing you could do for a yard tree that was damaged. And so long as it doesn't get hit again the following growing season, it should probably bounce back and be fine. The main concern I have is for those forest trees that we can't take care of and that are getting hit multiple times a growing season, multiple years in a row. That's the biggest concern I have, for sure.
Robbie, towards the beginning, you mentioned that some of these persist in a tank, an application tank. So it's important to rinse the tank. There's a question about, what do you do with the water used to rinse the tank?
Yeah, that's a good question. places that handle this type of stuff appropriately have rinse out stations, and that rinse water goes to a special holding tank, and then it's dealt with in an appropriate way. So for example, MU and their Bradford Research Farm here in Columbia, they've got a really high-tech rinse out facility. And I'd like to think that, you know, MFA and some of these other private custom applicators also are rinsing tanks out appropriately. I don't know. I don't visit their facilities. But as a homeowner, how do you rinse out appropriately? I'm not sure. If you rinse it out and you send it into your septic system, if that's okay. I do know that when people rinse it out in their gravel driveway, a lot of times whatever the chemical was will be taken up by any tree roots in that driveway, and then you see damage on those trees for years to come. I have several examples of that. So you got to be really careful where you're rinsing out, because tree roots are everywhere. You know, they grow a great distance from where the tree's trunk actually is, and they're actually really shallow. So yeah, be real careful when you're rinsing out.
We have a couple different questions here. One sort of related to that answer that you just gave about, do the chemicals stay in the ground after watering or rain? And then another that was more broadly, how long before these chemicals stop persisting in the environment and having an effect on plants, insects, birds, etc.?
Yeah, so we think that dicamba breaks down in the soil, you know, within a month or so. 2,4-D, maybe along those lines, maybe a couple of months. Note that dicamba and 2,4-D are widely used in the weed and feed products that homeowners can buy at Lowe's and spread across their entire lawn and then kill dandelions. So dicamba and 2,4-D, they do have some soil persistence. If they get into groundwater, then they're actually really stable in that groundwater. But I think most of the time, you know, in order to get to groundwater, you got to go through a lot of soil. And so I think most of the time, you know, it binds to soil particles and it breaks down, you know, fairly quickly. But it is a concern, especially for smaller plants. If this, let's say this comes down in rainwater, which we know it can. It comes down in rainwater, that spring ephemeral, that Virginia pennywort, it has a root system, but not a real deep one and not a real extensive one. Is it enough to damage that root system? Yeah, we don't know, but that's certainly a concern that we have. And then trees have really shallow root systems, actually, and most of those fine feeder roots that do all of the nutrient and water uptake are pretty close to the surface, like within the top 18 inches or even 6 inches of soil. And that's where, you know, some of this rainwater with these chemicals could be contacting those roots. So yeah, just another unknown, but definitely a concern.
Robbie, we have again a few questions that are related that are largely what individual people can do in their own home and garden situations. And so I'm
Sure.
just going to kind of wrap those into one. So someone's wondering about the volatility of tordon, and another person is wondering like about glyphosate, particularly for yard use. And again, in relation to those things, someone is asking about the labeling on the products, and that may be correct, but who monitors it, and like what can we as individuals do as far as minimizing any negative impact from things like tordon and glyphosate that are used in a home setting quite often.
Sure. Yeah. So, you know, as a homeowner and a gardener and whatnot, and a native plant enthusiast, I feel that the best thing you can do is try to avoid all pesticides in your lawn if at all possible. You know, when it comes to glyphosate, there's lots of opinions out there. You know, people get pretty wound up about glyphosate. The more I learn about some of these other chemicals, the less concerned I become about glyphosate, in all honesty. Glyphosate is a problem when we look at it across, you know, 200 million acres of agricultural land. Anything we spray on 200 million acres of land is going to be an issue. And it's probably an issue in our food supply and things like that. But when we look at glyphosate in an individual homeowner's yard, to me, it's one of the safer herbicides from a tree damage, plant damage perspective, because in general, it doesn't volatilize, it stays where you put it. As long as you didn't drift it onto a tree, then it's probably going to kill that plant next to the tree you wanted to kill, but it won't harm the tree. Now, if you get it onto a tree's bark, glyphosate has been shown to penetrate bark, and it will stay in a tree for 5 years at least. It doesn't break down in the phloem. It messes with the shikimic acid pathway. It causes reduced cold tolerance, and then you get all these splittings and cracks, and it's a nightmare. So you really want to be careful about glyphosate in a yard setting, because it's an active ingredient that's easy to come by, but the active ingredient hasn't changed over the years, but the products have. And so many of the products you could buy at Lowe's today, for example, have a lot of surfactants in them that would allow that dandelion to be killed by the glyphosate in 3 days instead of 10, like it used to. And those surfactants also will push it through the bark of a tree. So always read labels before you buy a chemical you're going to use in your yard, because it may say Roundup Power Max, but those, whatever that trade name is, can change year to year, and the actual active ingredient may be different than it was the year before. So just pay extra attention to active ingredients, and you decide for you in your yard what you're willing to put up with, as far as collateral damage, or what kind of chemical you're okay with in your yard. When it comes to Tordon, I've pretty much outlawed Tordon on my property, because it will go through the roots, and it kind of leaches out of the roots, and then roots from other plants that were off target can contact that and then be damaged by it. So here at our office, we've had some Tordon injury. I know of a couple of people that are department employees that in their own home area, they've had Tordon injury, and then that seems to stay in the ground for like 18 months after it's been applied. And so you continue to see damage. Let's say you applied it in your garden area to kill a bush honeysuckle. You won't be able to grow anything in that general area for quite a while. So I really caution against Tordon. I think that it's problematic.
Robbie, a couple people have asked about triclopyr and
Yeah,
whether it's an
triclopyr is a commonly
auxin.
used, triclopyr is very commonly used group 4 herbicide, plant growth regulator. It's one of the ones that the Forest Service, even on Mark Twain, has deemed acceptable. We've tested for triclopyr. Illinois has tested for triclopyr, and they pick it up sometimes. I don't think it is quite as volatile as dicamba and 2,4-D, but it certainly could have some volatile properties. I caution our staff to use it, to make sure you're not using it on a warm day, if at all possible, and to be aware that there could be some volatility issues with it. But to me, it seems like triclopyr is maybe more of a short distance volatility concern, than a longer distance issue.
Isn't
But
isn't
yeah,
it
we just
soil
haven't picked up.
active?
I don't know about that. Probably.
I
Most
thought I
of
thought
these
maybe
products are somewhat soil active.
I heard someplace that you could use it to treat things like Sericea lespedeza, but be careful of natives in the vicinity in the soil there because of that soil activity.
Right, and be careful of the timing. I think some of the Sericea treatments are done later in the fall when there's not that concern with volatility actually damaging the trees. Yeah.
There's quite a few people here with concerns about these specific chemicals, but also just the general feeling of worried about like how could you mentioned other ways to report it, but can you report things from last year, and also general concerns about where's the EPA, where are our regulators here? And I thought you touched on that very, very well. And I think that really truly part of the answer is we need to keep talking about this. So
Yes, and we need to talk about it more widely and put more reports out there. The farmers have kind of gotten fed up with reporting their own crop damage over the years because they don't get much of a response from the Department of Ag because they're severely overworked with all of this. But we need to be reporting more of the natural resource issues that we're seeing. And it takes a whole bunch of us being pretty wound up about it, I think, to get those reports out there. Can you report something from last year? No, not really. What you need to do is start taking pictures and reports this upcoming year and send them in as many as you can. honestly.
Thank you.
It looks like we have,
And
sorry, Robbie, go ahead.
Oh, I was going to say, where has the EPA been on this? You know, the EPA is a federal agency, and there's been some political issues with this topic specifically over the years. You know, that's why there's been several court cases, a couple of vacatures from the federal courts on these labels. You know, the most recent one was more of a proceedings issue than it was a damage issue. But yeah, I think it's pretty well known that these products were rushed to be labeled and sent out the door. And there's some political concerns there too. You know, my agency is not the regulatory agency with chemicals in pesticides in Missouri. That would be Missouri Department of Agriculture, that they handle all of that. So, you know, I have to be careful about what I say and where I go and what I do. But yeah, it's an important topic for sure.
It looks as though someone in the chat answered a question from someone in the Q&A. Basically,
Perfect.
Robin asks, future work for private citizens. And if everyone could take a look in the chat, Melinda Hamelgren speaks of Senate Bill 416, which is in the legislature right now. And her comment is very appropriate. So there are things that we can do for sure.
Yes.
Looking for tips to get rid of bush honeysuckle. People have problems with honeysuckle. Surprise, surprise.
Yeah,
And
for sure.
There's some
I don't have any
good resources.
silver
Are there
bullet for
good
that.
resources you could point people to if they have other issues and things trying to manage plants?
The Missouri Department of Conservation's website does have several pages on managing invasive plant species. I know we're trying to revamp those and get them all up to date, but there are recommendations on our website. There's a lot of good guides out there across the Midwest that help with that too.
Ethan, if you're seeing what I'm seeing here, because that there were quite a few questions about like home tips, but it looks like our last question in the Q&A is, are researchers in our university system interested in studying this? University analytical labs could be utilized to bring down the cost of testing? Question mark.
Yeah, it's an interesting issue to study at a university level. So yes, I can assure you that a lot of this has been pursued with different people. I've had a lot of talks with various universities across the U.S. There's a lot of hesitation, particularly from land grant universities. Wink, wink. Maybe one's even in my own town here. There's the Monsanto building, you know, like Bayer Life Sciences. There's some competing interests there, maybe. And I think everybody kind of has to be careful about what they do. So yeah, this has been hard to, while I think there's a lot of people that are concerned about it, it's hard to study. It's a dynamic ecological system. It's not a lab setting. And a lot of the analytical chemists do lab setting studies, not dynamic ecological settings. So it's complicated for sure, but I'm pursuing every avenue I can on that. So.
Robbie, I've seen so many compliments here, just complimenting the excellent way you put together this presentation, the obvious hard work, your obvious expertise, your obvious dedication to this topic. And we definitely recognize how you carry yourself professionally through this, and provide the information, the facts that we need. And then you can always keep in mind us NGOs out there that are well armed with those facts, and it really helps us advocate stronger. And this is something that falls squarely in our wheelhouse, in our mission at MRBO. And I look forward to future conversations with everybody about this, as however we can, because it takes everybody. Everybody here can make a difference some way, and we can move the needle forward on this.
Right. Thank you. I appreciate that. I'm glad to have you guys on board for sure. Yeah. Thank you.
Robbie, I think what I'm going to do is I'm going to send you the chat in its entirety. But someone says Verbo has had really great webinars, but Robbie has raised the bar a bit more. So I wanted to share
Man,
that.
I don't know.
So
There's some great people that went before me, so just trying to keep up with the pack.
all right. If there's no more questions, we'll let everyone go. Robbie, hopefully we get to talk to you soon.
Okay, thank you. Thanks everybody for
right.
your time.
Thank you.